What's up, kiddos? Okay, so far, here's what we've done. We've learned how to find the lateral surface area and total surface area of a prism, no matter what the base of it was, no matter what the name of the prism was. We learned how to find the total surface area of that. And then the next one we talked about was finding the total surface area, including lateral surface area, of a pyramid. How do you find the total surface area of a pyramid? Well, here's what I'm going to do in this video. I'm going to compare those two and parallel them with the next two solid shapes. One called a cylinder and one called a pyramid. So that is the essential question for this particular video. It's really two essential questions. The first one is, how do you find the total surface area, including lateral surface area, of a cylinder? And then how do you find the total surface area, including lateral surface area, of what we call a cone? So as you see behind me, you need your foldable, of course. You're going to see a comparison of prism, of which we already know a couple characteristics of, and a cylinder, of which I know you should know the shape, what it looks like, but let's compare the characteristics of these two things and see how similar they actually are. I wish I had the shapes with me. I don't. I'm actually at home, so all I can find is this. In my basement I found an old paint can. Now you can think of a soup can, you can think of any type of a can, whatever, but this thing right here is an example of a cylinder. So you see some comparisons if you think about exactly what a prism was. The only difference, I guess, really, well, there's a couple differences, we'll see. So let's compare, let's look. So over here to the left, a prism. We knew this, the first characteristic of all prisms. They had two congruent parallel faces, and we called them the bases. And remember, the base can be any type of a polygon, but we named the prism itself by the name of the polygon that was the base. So a hexagonal prism, triangular prism, so on and so forth. Well, over here, it sure does look like a prism, except this, remember, was a polyhedra. It was flat faces. There's nothing here really that's kind of flat other than maybe the top part and the bottom part, but there isn't anything flat on a cylinder. So this is a different type of a solid. But there is a characteristic that's the same. It has two congruent parallel faces that we call the bases. The only difference, as you know, a cylinder, the actual bases are always going to be circles. Always going to be circles. You know what a cylinder looks like again, but there's your actual base, and there's the base. They're always going to be circles. That's actually nice, because in a prism, if you remember, you had to remember how to find the area of all kinds of different polygons. Well, the base is always going to be a circle. So that's a little easier in that regard, and you'll find out. Now, over here we had lateral surface area, of course. We have lateral surface area of this, which is actually taken care of a little bit different, because remember, in prisms, all the faces are flat. Well, that right there, this thing here, or this part, that certainly isn't flat. It's a circular piece. How do I find the surface area? That we'll find out. And then the last thing is total surface area. Notice this. It's the same thing. It's the lateral surface area plus the 2 times the area of the base. Excuse me. And then the total surface area is the lateral surface area plus 2 times the area of the base. So that is exactly the same. And there is lateral surface area, which we'll find. So let's dive into this a little bit more. Again, all I'll be putting on your foldable is just the cylinder part for the cylinder part of the foldable. We've already done the prism. So those things right there. You might hear me say a couple other things that you can put in there too, other than what you see up here on the board. So here's an example of a cylinder. This is theorem 113. Holy. Lateral surface area of what we call a cylinder. Well, here's how it works. As a similarity to a prism, we found the lateral surface area, remember, by finding the perimeter of the base and then taking that times the quote-unquote height, distance between the two bases. Well, I'm going to tell you that's exactly how you find the lateral surface area of a cylinder. But wait a minute, let's think about this. The perimeter of this cylinder is nothing more, kids, than this. It's this piece right here. Now, if you look at that shape, what is that purple thing that I'm drawing? Well, that's just the rim, if you will. It's just the rim of this particular cylinder. But if you look at the base, it's a circle. So as I just put here, it is basically just the circumference of that particular circle. And we've heard that before. Circumference is the same thing as perimeter, distance around the circle. So we find the circumference, and we take that times the height. So C is for circumference, H is for height, and that's your formula. That's theorem 113. Now there's other things that you can write, as you can see. Circumference, as we know, two different formulas for circumference. It's pi times d, or it's 2 pi r. So any three of these things will work. Maybe the circumference given to you right away. Sweet. Plug it in. Take it times the height. Done. Over here, take that. Maybe the diameter is given to you. Maybe the radius is given to you. But check this out. If I show you this paint can, and I actually look at the label is what the lateral surface area is. Well, if I take this lateral surface area and I just kind of do this with it, I cut the back of it and I just kind of pull it apart, what you're going to notice, hopefully you can see it, if I actually rip it off, that's the actual label. That's the lateral surface area that you're finding of any cylinder. Well, take a look at what the shape is. The shape of this thing, is nothing more than a rectangle. That's pretty cool. And to find the area of a rectangle is just base times height. And I believe this right here, the height of my rectangle, is the same as the height of the can. That's what the H is. And I believe this distance here, the actual base length from my fingers that I'm holding onto right there, that is just the circumference of the circle. That's all it is. So it's just a rectangle folded around a cylinder. So that's how you find the lateral surface area. It's pretty cool. Woohoo! Woo-wee! Celebrate. Okay. So, sorry, that was a little fun. So let's keep going. So that's lateral surface area. Now let's add one more little piece to it. The total surface area. Well, that's great. I can find the total surface area by, of course, finding the actual lateral surface area and then add the area of the two bases. So I take 2 times the area of one base. Remember, the base is just pi r squared. That's the area of a circle. And here is your formula right there. Matter of fact, if you look on the PSSA formula sheet, I believe it looks very similarly to this. So all you got to do is this. You can just take the r, which is the radius, bam, right there, and plug that in here, plug it in here, and find the height, plug them all in there, and calculate it properly, and you'll get your answer. Here's an example over here to the left. I've done an example here. Diameter is 10 inches. The height is 14. So if the diameter is 10, that means my radius would be 5. So to find the lateral surface area, well, I have to find the circumference times the height. So wait, I know the diameter, so I'll just plug it in here. So diameter is 10, height is 14. That's what I put here. Diameter 10, height's 14. Multiply all that out, I get 140 pi inches squared. That would be the lateral surface area. It would be the area of the label, if you will. So the total surface area now, I take 140 pi, and I'm going to add that to 50 pi. Where did the 50 pi come from? That is the area of the two bases. Because when I find the area of one base, pi r squared, I take 5, which would be the actual radius, and I square that, because that is my circle formula for area. So pi times 5 squared is 25 pi. I take 2 times that, like I did right here, and I get 50 pi. So I add those two numbers together, 140 pi plus 50 pi, which gives me 190 pi units squared. So there is the total surface area of that particular cylinder right there, if it had a diameter of 10 and it had a height of 14 inches. Lovely. So there is your cylinder. Very similar to a prism, although I think it's a little easier because the bases are always exactly the same. So there you go.